Welcome back to another episode on the Mind and the Machine. Today I'll be introducing the HC-SR04, aka the ultrasonic sensor. This is a really cool component as it measures the distance between an object and itself through bursts of ultrasonic sound waves, and it calculates the time taken for it to reflect back to the sensor. The same principle for echolocation. It has 4 pins: VCC for power, trigger, echo, and the ground pin. Now let's see it in action. For the circuit we will need the sensor, 4 male to female jumper wires, and we'll connect it as shown on the screen. To program this, we will open up the example code through going to File, Example, Sensor, then Ping. Now the code may look a bit confusing, but to put simply, you'll see a constant variable called ping pin as 7. We must change the code for it to suit our sensor, so we add a new constant as echo pin and we set it as 8 and rename ping pin to trig pin so it matches our sensor. Next is to introduce the constant trig pin as an output, as it will trigger the pulse for the whole process to begin, and echo pin as an input as it measures the return pulse. We can now delete the line shown on the screen and edit all the variables named ping pin to trig pin. Then change the variable in the duration calculation to echo pin, and lastly change the value on the line shown from 5 to 10 milliseconds. You can now use your hand to see the varying distance through the serial monitor as shown. I've also upgraded it by integrating LEDs to signal different distances. Just something small you can apply here. The code for this is as shown. This new component can be a massive help in many projects and opens so many doors. But this next component is quite different, and it's a piezo buzzer. It creates noise through vibrations, and changing the frequency of the current can change the frequency of the noise made. You will need a passive buzzer and 2 jumper wires, and connect the positive end to the Arduino pin and the negative end to the ground pin. To program this, you will introduce it as an output and begin to use the tone function, where in it you can state the pin used and the frequency you want it to play. In this code you can see the frequencies of music notes, and it should sound like this when you upload it. This is getting boring. How about we take both components to make a system, one that is used in almost everyday life. For some, it's an Apple AirTag. For others, it's in planes. And for most, it's in cars. And that's a proximity alert system. For this, we will need the sensor, 6 jumper wires, and a piezo buzzer. I haven't used any male to female jumper wires to show a different and easier method to use the HC-SR04. Connect the wires as such, ensuring the pins and sensors are in the same row so that they are electrically connected. Then simply, anywhere in the circuit, add the buzzer to a pin of your choice. To program this, it will be the same code as the original sensor code, but we have to introduce the buzzer pin as a constant. Then make it an output and use an if statement to say if the distance variable, or centimeters, is less than 5 centimeters, then turn the buzzer on to play this frequency, or else turn the buzzer off. It's that simple, and once you upload it you can try it out. Now I'll move my hand to test it out. Isn't it awesome? That will be all for today's video. Hopefully I didn't confuse anyone, but until the next one, take care.